Hello. I wanted to show y'all how to build the operating system, and I was playing around with it a little bit, and I did get it to work on Windows using WSL. So that's how we're gonna do this. Um, you're also gonna need VirtualBox. Uh, I guess it doesn't like VMware, um, but we'll get to that part later. Um, we'll start with WSL. So this is just like an Ubuntu container um, that runs on Windows, and we can build Redox inside that. So it's just WSL dash dash install. Um, and if you've never run WSL before, um, it's probably going to make you like install some like prerequisite stuff and then have you reboot before it'll have you do this again and then actually install Ubuntu. We'll just give this a second. All right, and then once the container is started or VM, I'm actually not really sure how WSL works to be honest with you, but I know that it works for what we're doing. So um, your username doesn't really matter. Just put my first name, but you're gonna want to remember your password um, because you're gonna need it a lot for like installing things. So you need to put your password in a lot. Yeah. So now that we're here, uh, we've got our Ubuntu terminal, and we can look here. There's nothing in our home, and then if we look at the root directory, so this would be like C drive on Windows, but it's just root with one slash on Linux, and we can see we have a bunch of stuff here. This is just like operating system Linux stuff. We don't need that. Um, we do need. We'll put this over here. We do need this section 2.5 in the book. Um, it explains a lot of stuff in here. This is good to read through, but here I'm just gonna use the new working directory instructions and copy paste the commands. It's probably the easiest way to get up and running. And then once you've got this, um, you can take the existing directory and do stuff with it, and then yeah, we'll get there in a minute. But to get started, you can make a directory and put it in a specific place if you'd like. But I'll just put it right here in the home folder since this is the only thing I'll be using WSL for. Um, so we will grab this curl command right here. All this is going to do is download this sh script and put it in the folder. sh is like .bat on Windows, but it's for Linux and other like BSD, Unix. I'm pretty sure that like Mac OS will take those as well. And then our next command, this time just counts the time and puts it out at the end. Bash is like the terminal. That's what the sh is for. But it does, yeah. We can just copy paste this, and it'll run the script. It'll take you through a few things. The Rust, just hit enter. And this will take some time. So this is just, yeah, like this is just installing Rust into WSL. And the script will go and grab us a few other things, and then I'll come back because, yeah, this is why you're going to need your password a lot, because it will prompt you a few times for this, and it'll prompt you for another, a couple more like yes, no questions. There we go. All right, and once the bootstrap script has finished running, there's a couple more things we're going to need. And to install them, we're going to use sudo apt install. So sudo is just like run as root, run as administrator. Apt is the package manager. If you're using Debian, it's always going to be apt. So Ubuntu, Linux Mint, Pop OS, a lot of stuff's built on Debian. It'll use that. Other versions of Linux use different stuff, and you can even change this and add other ones. But I don't know about all that. Install does what you think it does. And then we want to get libfuse3-dev. This is something with storage. I don't know what it does, but it's pretty important. And then the other thing we're going to want to get is build essential. And this is just like C compiler and some other stuff that I'm guessing is for like the ported applications and like stuff that wasn't written in Rust, but like games, like non-core. All right, and then once that's done installing, we can source this directory here. So what this will do, this little tilde, you'll see it here. It's the same thing. It's just your home directory. So in Windows, you have like your users, and then whatever your user is, and like this is your home. Oh, I don't know what I did there. And this is your home directory. It's just shorthanded like this in a lot of versions of Linux. And then this is just the directory to the Rust tools, or the Rust environment. And then once we've done that, we can time make all, and this will take quite a while. Oh, my bad. Forgot to, you have to make sure that you're in the Redox directory, because the Bootstrap script makes that. You'll see if we list here, it's the only thing in our home folder now. So we can change directory back in there, make all, and so the part of the reason this takes so long is because you'll see it's downloading and then installing a bunch of stuff. It's doing this on top of another container with the Podman or something. I'm not 100% sure. But then what the Bootstrap script installs isn't the code, but it's just all of the the information set up to then build the operating system. And so we'll get to this in a minute once this is finished, but we can drag our own code in there, and then it will build. Oh, one more thing. I forgot about this one. It gets upset. I have no idea what this is. And so we want to apt install package config. My bad. And then now, we'll do the time on that. Now it'll run without issues. Yeah, we can copy our code in later, and then it will work. But we can also in the GitLab, like all of the code is separate. It's not just like one big repository for all the stuff. It's like the kernel has its own repo, and then the log daemon has its own repo, and all the drivers have their own repo, and yeah. And then what we're doing with the Podman, this script here, is it just downloads all the stuff we need, and all the information is to tell the compiler, okay, go download this, and then build it, and then it goes into the other things as well, I guess. It's kind of cool. And we'll see in a minute how that makes it pretty easy to get our stuff compiled and built in to the operating system. But we'll just let this finish. It'll take a while. All right, so now that that make all command has completed, you'll see something like this at the end. It's going to give you the directory to the hard drive image, and so on Linux they have you do this make QEMU. But if we do that, it'll spit out some stuff and then tell you no. I think I'm actually this one might work. No, it doesn't. Anyway, we need to make an ISO file to make it work with a virtual machine on Windows with VirtualBox, and that's just make live. and we'll give that a second. This one will be a lot quicker than the last one. All right, and now that we have that, we let's go and take a look at it in the directory here. So, with WSL, it gives you this this mount here to your Linux system, and we want to go to the home, whatever the home is, and then we'll see our Redox directory, build x8664 desktop, and we've got this live disk ISO right here. We might be able to just get to it straight from here, yeah. It is quite a, oh, sorry, that's looking for a virtual machine file. No, new, sorry. Once we have the new, give it a name. It can have a folder. And we will just, I have one on my desktop from earlier, but we'll just go grab the one that we just made. It might be worth even pinning that up here. Oh, I don't remember how this works. Anyway, bookmarking that somehow might be useful. But for now, we'll just grab that. Linux, we'll just keep it as that. It doesn't really matter. We want other Linux. And then we can get away from this unintended install stuff. Just give it like, it's like 4 gigs of memory. And then we'll give it 4 cores. And then enable your EFI. And then we will not be adding a virtual hard disk. I haven't really played with this. You might be able to properly install it. But I think that there's still some buggy stuff with the installer. So for now, we'll just take a look at the live disk. And it is saying... Oh, because I created one with this name before. Okay. So now we can just double click on that to power it up. And it's auto capturing our mouse and keyboard. So here's our boot screen. Give it the whatever resolution. And then with VirtualBox, you use your right control key to grab control back to the main operating system. There's no login required, and so if we go and do that, now we can get in here, and we can see that we do have access to the internet, but there's not a whole lot of like interesting stuff to do in here by default. A calculator, but it is very easy to build in our own code. And there's also like some package install stuff. Actually, I'm not even. I'm not sure if this is going to work or not. Yeah. All right. So to build in our own code, we're going to go into our Redox folder, and we're going to want to go to the cookbook and recipes. And while we're waiting here for a second, in the recipes folder, you can also follow along in the book here in section 9. It's mostly the same thing, and then they also explain later how you can get set up at just doing a hello world in here. But I've got downloaded from GitHub the zip file that has my code in it here. And what we're going to do is we're going to create a new folder in the recipes directory. We're going to just call it Mandel. That's the name of the program. And then in here, we're going to drag in that source folder from GitHub. You also could totally like git clone directly into it from the Linux WSL, but this way is a little bit more visual, I guess. And then in here, we're going to rename that folder to source, and that's got the source code in it. Oh, that was loud. It's got the source code in there. But more importantly, this cargo toml, which has the name of the program. Here's the source if you want to see. And then it's got our dependencies. And then we have another toml file we're going to create. I'm just going to copy paste this one to avoid some messing around with Notepad. And we're just going to rename this to recipe.toml. And in here, we're going to want to paste these two lines. And they explain a little bit more why in here. And then if you look around in some of the other recipes for the stuff that's built in, you'll see that you can actually define where the source comes from as like a GitHub address or a GitLab address. And that's kind of like a little hint into how the build system works. Once you have that recipe.toml in that Mandel folder with the source code and all that, we're going to go all the way back out to the Redox folder. And then in the config folder, and they talk about this down at the bottom here. We're going to go to desktop, and then we're going to put in our Mandel program. And then I'm also going to add Redox games for fun. So now we're going to go back into the Linux container, Linux environment where we're building this, and we're going to make r.mandel, and we're going to give that a minute. It shouldn't take too long to just do onesie twosies. Yep. And then make r.redox. Oh, that's a dash, not an underscore. And then we can make all again. It says nothing. Make live. It might give you more for that make all. I've been messing around with this, so it might just be fine for me. But we are going to want to make live again to get that ISO. And we'll see that that's spat back out in the same place as before. So we can grab VirtualBox and put in our resolution. And we'll go ahead and we'll wait for that, I guess. Log in. Grab the mouse. And then now if we open the terminal and type in the name of Mandel, the application, and hit enter, we'll see that it runs. And then we can click on it. It will drag the whole system down for a second. But it will then advance. You can look at the code. It advances the power something or other. I'm not a math major. Somebody else can explain that better than I can. But it looks pretty, I think. We could also cd/bin So bin is for binary. That's just like your binary applications. And we can take a look at what's installed here. I think there's also it says it in here, doesn't it? List packages. Oh, underscore. Oh, I guess it doesn't. Anyway, in here we can see some stuff. A lot of the games in here don't work. I think I'm not really sure, but Redoku does. Um, uh, and then we can play some Sudoku. Um, so what? Okay, one thing I forgot while editing this together, to update the code, there's a command make pull, and you'll see it's going to go to GitLab and get everything that's changed, and then once you run make all again, this is probably going to take a minute, but it'll have all the updates to the code. And once you've done the make all command again, then you do make live, and you get the ISO with the updated code. Yeah, that's it. Thank you.